Greetings everyone. On behalf of Thinknyx Technologies, I'm thrilled to have you join us for yet another captivating video tutorial. Today, we're delving into the intriguing world of Helm, the Kubernetes package manager, and we're excited to be your guide on this learning journey. Kubernetes takes the throne in container orchestration, yet the intricacies of deploying and managing applications can be daunting. That's where Helm, the Kubernetes package manager, shines by simplifying the process. In this tutorial, we will delve into what is Helm, why is it used, explore its significance, discuss its key terminologies, guide you through the installation process, describe the Helm chart structure, showcase how to operate effectively with Helm, and finally conclude with key takeaways. Helm is a package manager for Kubernetes. It's a tool that simplifies the process of defining, installing, and upgrading applications in Kubernetes, thereby easing the burden of managing multiple YAML files and intricate application dependencies. Built on the principle of simplicity, reusability, and efficiency, Helm introduces the concept of charts, which are pre-packaged collections of Kubernetes resources and configurations. These charts, encapsulating everything from container images to configuration settings, empowers users to effortlessly define, install, and upgrade applications. With a strong focus on ease of use and collaboration, Helm not only enhances the manageability of Kubernetes deployments, but also promotes the sharing of best practices and applications within the Kubernetes community through its central repository artifact hub. Whether you're a seasoned pro or a newcomer to container orchestration, Helm is your guiding compass in the intricate Kubernetes landscape, enabling precise control and flexibility in application management. Let's explore why was Helm needed. One of the most burdensome tasks that Helm resolves is application packaging. It simplifies the packaging of Kubernetes application into charts, which bundles all necessary resources and configurations. This standardization streamlines the distribution of complex applications, ensuring consistency in deployment across clusters. Efficient deployment. It offers a set of commands for installation, upgrade, and management of applications, abstracting the complexities of Kubernetes manifest. This abstraction reduces the learning curve for Kubernetes beginners and accelerates the deployment process. Reusability and consistency. Helm charts are highly reusable, allowing users to share and deploy applications across various Kubernetes clusters and environments. This reusability promotes consistent application deployments and saves time. Helm also helps in customization and flexibility. It enables easy customization of charts through values.yaml. Users can tailor application configurations to match specific requirements, ensuring adaptability to diverse deployment scenarios. Lastly, Helm fosters community collaboration through Artifact Hub, a central repository for sharing and discovering charts. This promotes knowledge sharing, best practices, and the collective development of Kubernetes applications benefiting users worldwide. Here are some of the key terminologies used in Helm. A Helm chart packages all the necessary resources and configurations for Kubernetes applications, ensuring they are easily shareable and deployable. Helm manages instances of charts deployed in Kubernetes cluster through releases, making it possible to track and update applications throughout their lifecycle. Repositories are a collection of Helm charts that can be packaged and distributed, simplifying the process of sharing, discovering, and distributing charts within the Kubernetes community. Helm employs Go templates to dynamically generate Kubernetes manifests, allowing for the on-fly configuration adjustments to meet specific deployment needs. Values.yaml is a configuration file that allows customization of Helm charts, permitting users to tailor application settings and parameters for diverse deployment scenarios. Chart.yaml is a metadata file for Helm charts, containing information such as name, version, and dependencies, facilitating chart management and sharing. Helm introduces hooks. These are predefined actions that trigger a specific point in release lifecycle. They empower you to perform extra operations like database migration or configuration seamlessly during application deployment. Users can extend Helm's capabilities with custom plugins, adding unique features and commands to address specific requirements and enhance its functionalities. Installing Helm is a straightforward process. Here are the steps to follow. We can also refer to the official documentation site helm.sh for details. Step 1. Download Helm. Visit the Helm GitHub release page and download the appropriate binary for your platform. For Linux users, we can utilize the following commands. The first command downloads the Helm installer script from the official Helm GitHub repository. Next, we need to make the script executable using the second command. And now that the script is executable, we can run it to install Helm on our system. Then we confirm the successful installation of Helm by running Helm version. Both the client and server version should be displayed. Helm uses charts to define the structure of Kubernetes applications. A Helm chart is a collection of files that define a set of Kubernetes resources, along with a set of customizable parameters. Here's an overview of the Helm chart structure. For generating a basic structure of Helm chart, we use the command helm create mychart. By executing this command, the following structure gets created. Here, under the mychart directory, chart.yaml contains the metadata for the chart. It includes information such as the chart name, version, description, and maintainer details. If your Helm chart depends on other charts, you can place those charts in the charts directory. Helm will then automatically manage these dependent charts when you install or upgrade the main chart. The templates directory contains the template files for Kubernetes resources, such as deployments, ingress, services, service accounts, etc. that will be created when the chart is installed. Here, _helpers.tpl is a special file used in Helm charts for defining template helper functions. These templates use co-templating to insert values from the values.yaml file. The template file typically has a .yaml extension. Values.yaml contain default configuration values for the chart. Users can override these values when installing the chart, which allows for customization without modifying the chart's templates directly. With Helm successfully installed, let's explore the most used commands. First, Helm create. As discussed earlier, the Helm create command is used to generate the basic structure of a Helm chart. This command creates the necessary directories and files for a Helm chart. For example, helm create mychart. This command will create a new Helm chart named mychart with a standard chart structure, including the templates, values.yaml, and other directories and files. Second, Helm lint. The Helm lint command is used to check the syntax of our Helm charts and ensure they are correctly formatted. It helps identify issues before we deploy the chart. For example, helm lint mychart. This command checks the mychart for any syntax errors or formatting issues and provides feedback. Third, Helm package. The Helm package command packages a Helm chart into a versioned archive file that can be easily distributed and shared. For example, Helm package mychart. This command packages the mychart into a tarball, creating a file like mychart-1.0.tgz. Fourth, Helm install. The Helm install command is used to deploy a Helm chart to a Kubernetes cluster. It installs the chart and creates a release, which represents the deployment instance. For example, Helm install myrelease mychart.tgz. This command installs the mychart.tgz as myrelease on the Kubernetes cluster. Fifth, Helm ls. The Helm ls command lists all the release deployed with Helm on Kubernetes cluster, providing information about the status. For example, Helm ls. This command lists all the release, including their names, chart names, and status. Sixth, Helm Status. The Helm Status command provides detailed information about a specific Helm release, including notes, if any. For example, Helm Status My Release. This command displays information about the My Release deployment, including any notes associated with it. Seventh, Helm History. The Helm History commands shows the revision history of a specific Helm release, allowing us to track changes and roll back to previous versions if needed. For example, Helm History My Release. This command displays a history of all revisions for the My Release deployment. Next is Helm Upgrade. The Helm Upgrade command is used to update an existing release with a new version of a Helm chart or modified configuration. For example, Helm Upgrade My Release space My Chart new.tgz. This command updates the My Release deployment with a new version of the My Chart new.tgz. Next is Helm Uninstall. The Helm Uninstall command removes a release and deletes all associated resources from the Kubernetes cluster. For example, Helm Uninstall My Release. This command uninstalls and deletes the My Release deployment from the cluster, cleaning up all associated resources. The next command is Helm Repo. The Helm Repo command manages Helm chart repositories, allowing us to add, list, update, and remove repositories. For example, Helm Repo add stable and the URL of the repo. This command adds a new repository named stable with the URL to access Helm charts from that repository. Helm is a powerful tool that simplifies Kubernetes deployments for beginners and experienced users alike. With Helm charts, you can effortlessly package, share, and manage complex applications. Helm simplifies complexity and boosts consistency. It offers customization through value files and integrates seamlessly with the CI/CD pipelines. Helm security enhancements and vibrant community makes it a reliable choice. Embrace Helm for a smoother Kubernetes journey. Whether you're starting out or advancing your skills, it's your compass to success in container orchestration. That wraps up today's tutorial. If you found it helpful, don't forget to hit the like button and subscribe for more. Stay tuned for the next part where we'll dive into hands-on demo of Helm. Until then, happy helming!